All right, so this is another example, example 1C, and we're going to work out what the shear force and bending moment is for this beam. So just like all the others, we'll start by taking the moments about, how about we take them about B. Okay, so we're going to take the moments about B, so this point here. So the clockwise moments must equal to the anti-clockwise moments. So this distance here is, okay, so that's RD. So the distance would be, so we'll say 5, because 3 and 2 is 5, 5RD plus, and this one here is also going anti-clockwise, plus 1 by 30. That's equal to the clockwise moments, which is 3 by 50. And that's it. And then to solve for that, we get RD is equal to 24 kilonewtons. Okay, now work out RB. So we'll take maybe the moments about D. We will say that 5RB. Okay, so 2 and 3 by RB here. 5RB is equal to 2 by 50 plus 6 by 30. Okay, so yeah, we have this 2 by 50 going that direction and 6 by 30, and that's counteracted by this one. And when we solve that, then we get RB is equal to 56 kilonewtons. And now we just do our check. So forces coming down is 30 plus 50. That's equal to 80. That's these two guys. And what's going up is 56 RD, 24 and 56. 56 plus 24, and that's also equal to 80. Okay, so everything is balanced, and I have a degree of confidence in these numbers here. All right, so we can start now to get the shear force and bending moment equations. And we'll start by taking a segment here between A and B. So I take this segment here, show the shear force of V from A to B. And we just look at the forces going to the left of that, and that's equal to minus 30 kilonewton. And then the moment from A to B, and we call this distance X, that is minus 30 kx. Then if we take them from B to C, maybe I'll do this in a different color. There, so if we look at the shear force from segment B to C, well, what are the forces to the left-hand side of that? Well, it's minus 30 plus 56. So VBC is equal to 26 kilonewtons. And I want to get the moment from B to C. Well, that moment there is equal to minus 30 k times x. And this one here is going in the opposite direction, so it's plus 56, and that distance is going to be x minus 1. Okay, so if that value is x, that value is 1, then that distance there is x minus 1. Okay, and when we multiply that out, we get MBC is equal to 26x minus 56. That's kilonewton meters. And finally, we look at from C to D. So we're going to look at a segment in here. Voltage, or not voltage, the shear force from C to D. That should be equal to everything on the left-hand side, but we also know that's going to be equal to everything on the right-hand side. So I should get 24k, but let's just work it out anyway. So I have minus 30k plus 56k minus 50k. And if I add them all up, I get 24k. And if I want to get the moment from C to D, maybe start from here, moments from C to D, well, we just add them all up. So that now becomes x. So I get minus 30k x plus 56 times x minus 1 minus 50 times x minus, so that's 3 and 1 is 4. And when I multiply that out, I get MCD is equal to minus 24x plus 144 kilonewton meters. Okay, so let's have a look at that on the next slide where I've typed it out. So there's all our shear force and bending moments. So we said from the shear force from A to B is minus 30 kilonewtons. So, okay, so from A to B, so it's minus 30. And then from B to C is 26. So it comes up here, 26, and continues that all the way over to C. And then at this point here from C to D it goes to minus 24. So it comes back down to minus 24. And then it hits the 24 kilonewton here and brings it up. So that's the shear force. The bending moment, it's from this point here, it is minus 30x. So so x is 0. So at this point x is 0, and it grows. So this distance here is 1 meter. So it's minus 30. And then from here it's 26x minus 56. So x here might be 4. So we put that value in, we get this, and so on. And I will show you how to do those on an Excel spreadsheet to plot those graphs. Okay, so that's our shear force and bending moment diagrams.